Hello learners, welcome back to EduRev. I hope you remember what all we studied in the last lecture about real numbers. Today, we will step a little forward and solve a few questions to brush up our understanding. So without further ado, let's begin. So, our question 1 states that we need to find a rational number between root 2 and root 3. Now keep in mind, this is previous year board exam question. That means if you're able to solve this, then you can easily crack all the other questions related to the topic in your boards. So let's get started. So we basically need to figure out a rational number that is between what? Root 2 and root 3. Now I know this might be a little bit confusing, but let's guess, alright. So let me assume that there is this number p that is a rational number and that lies between what? Root 2 and root 3. Now if p lies between root 2 and root 3, can I write it in this equation that root 2 is less than p and root 3 is greater than p? So I can easily mention p in this equation, right? Now what I can do? Now I know that root 2 is a positive number. I know that p and root 3, like just forget about this p for a second, okay? We know that root 2 and root 3 are what? Positive numbers. And if p lies between two positive numbers, then that means p is also a positive number. Alright. So if I'm going to square this equation, then there is going to be no change in the inequalities, right? I do not have to worry that, suppose if I would say that minus 1 is less than what? 0.5. Okay, so if I'm squaring it, then minus 1 will be 1 and 0.5 square is going to be what? 0.25. Now obviously 1 is greater than that, so the inequality will be what? Reversed. But since both numbers are positive, that is on the left hand and right hand side of p, that is root 2 and root 3, so both of them are positive. So if I'm going to square these numbers, then I do not have to worry about the change in the inequalities that are present in my equation. So problem solved, right? So when I'm going to square it, my equation will be what? 2 is less than p square is greater than 3. Now, this is the equation that I get. Now, the perfect squares which lie between 2 and 3 are going to be what? The perfect squares. Let's guess. Okay. So, I need to find out what perfect squares between what? 2 and 3. So, perfect squares which lie between 2 and 3 are going to be what? 2.25 is going to be a perfect square, right? 2.56 is going to be a perfect square. Similarly, 2.89 is going to be a perfect square. Correct? So these are going to be perfect squares which lie between what? 2 and 3. Now if I take square root throughout these numbers, that is square root of this, square root of this, square root of this. So I know what? I know that 1.5 whole square is going to be 2.25. So 1.5 square is going to be 2.25. So 2.25 square root is going to be what? 1.5. Similarly, 1.6 square is going to be what? 2.56. So under root of 2.56 is going to be what? 1.6. And similarly, the square of 1.7 is going to be what? 2.89. So under root of 2.89 is going to be what? 1.7. Alright. So now the point is that the rational number that lie between root 2 and root 3, which I can easily find, is 1.5, 1.6 and 1.7. Now obviously the thing is that there are many more rational numbers that is between these two pair of numbers, that is root 2 and root 3. Right, there are so many rational numbers between them. But for the time being, we were only able to find what? 1.5, 1.6 and 1.7. And they basically asked one rational numbers because the question said that we need to find a rational number. So either you can report all these three or you can just report any one of these. So simple, right? I'll just explain one more time quickly so that you people, if any one of you got lost between the explanation, can come back on the same page with me at the moment. Okay. So basically the question said that we need to figure out what? We need to figure out a rational number that is between root 2 and root 3, right? Now I know that root 2 and root 3 are positive numbers. So between two positive numbers, I'll obviously have a positive number, right? So I wrote this equation, and because all these three are what? Positive numbers, I did what? square of all the numbers. So the inequality didn't change because all of them were what? Positive. Now, I wanted to find out the perfect squares between 2 and 3. And the things that came in my mind was 2.25, 2.56 and 2.89. And now I wanted to find out what p. I didn't want to find out p square. All these numbers are what? P square. But I wanted to find out what? P. So I need to do what? Under root of these. So when I did under root of these, I was able to find 1.5, 1.6 and 1.7. And these are the rational numbers between root 2 and root 3. And I'm going to repeat once again that there are more rational numbers between these two sets besides the one that I have mentioned. But for the time being, we calculated only these three. If you want to calculate more, you can find out more, you can think of more perfect squares which are between 2 and 3. And then you can find out how we can actually proceed and get to those rational numbers. So I hope you understood this. So let's move on to the next question. So the next question is from R.D. Sharma. So let's see what this question states. So this question states that if A and B are two odd positive integers such that A is greater than B. So they are saying that A and B are both positive and they are odd. So they are odd and positive, and A is what? A is greater than B. And then we need to prove that one of the two numbers, that is A plus B by 2 or A minus B by 2, is odd and the other is even. So basically what they are saying is they are saying that there are, alright. Now before I explain you this question again, I just want to tell you one thing. And that one thing is that you can see that this question comprises of 3 lines, right? So it might follow that when you are reading the question, there are so many important things which might get missed out while you are reading the question, and you might assume something else while you are solving the question. So it's always handy to underline the important words or the key words which are given in your question. Like for example, A and B are odd positive integers, so you can underline this. A is greater than B, you can underline this. And we need to prove that out of these two, A plus B by 2 and A minus B by 2, one is odd and the other is what? Even. So these are what? The key points. So let's see how we can solve this. Now what is given to us? First of all, let's see what is given to us and let's see what we need to prove. The thing that is given to us is that A and B are two odd positive integers and A is greater than B. And we need to prove that the two numbers that is given to us, that is A plus B by 2 and A minus B by 2, they are what? If one is odd, then the other has to be even. Okay. So let A and B be any two odd positive integers such that A is greater than B, that is given to us. Now since any positive integer is of the form what? Now the thing is that any positive integer is of the form q, 2q plus 1, right? Do you remember this? Do you people remember this? From where did this come from? Okay. So if you do not remember, I'll just give you like a little hint. And if you still cannot remember where all of this come from, then you can actually see the previous video of real numbers here on EduRev itself, which is like the video 1 of the real number series in your class. And in that video, we have explained that if I need to do, the cube of any number, so the number can be of the form 3m and 3m plus 1 and 3m plus 2. Okay, so these three were the numbers that were given. Okay, but now what? Now the thing is that if you those were like the cube, okay, and I have explained how we can figure out 3m, 3m plus 1 and 3m plus 2 in that video. Okay, so similarly, on the similar grounds itself, I can say that since any positive integer is of the form q or 2q plus 1. Now you can easily prove this if you have understood this question that I explained in that video. I'll again repeat that if you do not know what I'm talking about here, that is of 3m, 3m plus 1, 3m plus 2, and you just do not remember how that was done, then do click on that video first, see the question, and then come back to this video to solve this question. Okay, moving ahead, I'm just going to say that, since the positive integers can be of the form q and 2q plus 1, so let me assume that A is what? A is 2q plus 1. And let me assume that B is what? B is 2m plus 1. So I've just changed this and I've assumed that B is going to be this and A is going to be this. Okay. So I've just assumed that A is of some sort and B is of some sort, where Q and M like are some whole numbers. Okay, they are some whole numbers. So if this is the case, then what is going to happen? Just give me a second, I'll erase a little bit. Okay, so all right, now I know that what is A and what is B. Okay, so can I say that A plus B by 2 is nothing but 2Q plus 1 plus 2M plus 1 by 2, correct? So what is going to be A plus B by 2? So A plus B by 2 is going to be what? A plus B by 2 is going to be 2Q plus 1 plus 2M plus 1 by 2. So let's solve it. Okay, when I'm going to solve it, it's going to be what? 2Q plus 2M plus 2 by 2. So when I'm going to solve this, I'll get what? I'll get Q plus M plus 1. That is what? That is A plus B by 2 is nothing but Q plus M plus 1. Correct? Correct. Now similarly on the same grounds, I'm going to find what? I'm going to find this A minus B by 2. So let's just solve that also and figure out what is A minus B by 2. Alright. So alright, so for A minus B by 2, I can simply write that A was what? 2Q plus 1 minus B was what? 2M minus 1, sorry, 2M plus 1 upon 2. So when I'm going to solve this, it will be what? 2Q minus 2M, 1 and 1 got cancelled by 2. So this is going to be what? Q minus M. So that means A minus B by 2 is nothing, it is what? Q minus M. So now I know that what is my A plus B by 2 and what is my A minus B by 2. Okay. Now the thing is what? Now the thing is that it's given that A is greater than B. Okay, this was given. So basically what I did, I assumed that what is going to be A, what is going to be B. Now because I assumed that what is A and what is B, I was easily able to find what is A plus B by 2, and on the same grounds itself I was easily able to find that what is A minus B by 2. Okay, so that is sorted. I know what is A plus B by 2 and I know what is A minus B by 2. Now it was given that A is greater than B, which means what? Which means that 2Q plus 1 is actually greater than 2M plus 1. Okay, so I hope you understand this, that 2Q plus 1 is going to be what? It's going to be greater than 2M plus 1. Now if that is the case, I can cancel M and 2 from both hand side. This means that Q is greater than M. Okay, this means that what? Q is greater than M. Now just think of this thing, that if Q is greater than M, then you can see one thing here, that this is going to be a positive number. Correct? Because Q is greater than M. So when a smaller number is subtracted from a greater number, a bigger number, then the result which comes out is what? Positive. So that means A minus B by 2 is going to be what? A positive number. Now we need to prove that one of the number between A plus B by 2 and A minus B by 2 is odd, and the other one which is left is going to be what? Even. Okay. So for that I need to consider one thing. And let's just, move towards the solution part now. Till now we have just, assumed that what is going to be A, what is going to be B. We figured out what is going to be A plus B by 2 and what is going to be A minus B by 2. But now we just have to figure out that also we figured out that Q was greater than M. Now we want to prove that one is odd and one is what? One is even. So let's consider one thing. Okay, let's try to make the equations now. If I say that A plus B by 2 and I subtract this number from A minus B by 2. Okay, so now what I'm basically going to do is I'm going to subtract these two numbers. Why? Because to solve this question I need equations, and I need what? I need material on the grounds of which I can decide that which number is odd and which number is even, and then I can prove the statement. Alright, so if I'm going to subtract these two, okay, let's subtract these two. So if I'm going to subtract these two, it will be what? A plus B minus A plus B by 2. So a and a will get cancelled. It will be 2b by 2 and 2 get cancelled. So at the end, it's going to be what? B. Alright. And we know from the proof that a plus b by 2 and a minus b by 2 are positive integers. Correct. Because a plus b by 2 is what? Q plus m plus 1. This is positive. And we also prove that a minus b by 2 is positive. Why? Because q is greater than m. So this is going to be what? This is going to be positive. And we know that the two numbers that is given, that is one is like the odd number, which we assume that one is going to be the odd one, and the other one which is going to be the even one. So when I'm subtracting an odd and an even number, I'm getting b, right? So these are what? These are your positive integers. Now we know that the difference of the two integers is odd if one of them is odd and the other is even, correct? Because let's say I have 5 and 3. So if I'm going to like subtract them, it's going to be 2, that is even. But if I take two numbers from which one is even and one is odd, like for example, if I take 5 and 2, so if I'm going to subtract this, I'll get an odd number. So that means if one of the number in these two, that is a plus b by 2 and a minus b by 2 is odd and the other is even, so the subtraction of these two numbers should give me what? It should give me like an odd number. Okay? So it should actually give me an odd number. Hence, it is like also like the difference between the two odd numbers and the two even integers is going to be what? It's going to be even. Okay. Hence, it is proved that if a and b are two odd positive integers, then it has to be what? Even. Correct. So if a and b are two odd positive integers, then it's going to be what? Even. So it's proved that if a and b are two odd positive integers, and two odd positive integers is actually given in the question. So if they are two odd positive integers and if a is greater than what? If a is greater than b, then one of the numbers, that is a plus b by 2 and a minus b by 2, needs to be odd. And if one of that number is odd, then the other has to be what? Then the other has to be even. Got it? Okay, I'll just explain once more. Okay, so we got the result that what was a plus b by 2 and what is a minus b by 2, and we found out that both of these two numbers were positive. Then what did we do? We subtracted these two numbers and we found out b. Now we know that b is what? B is an odd positive integers. Okay, now that means b is an odd number. So when we subtract any two numbers and we get an odd number, then that means one has to be odd and one has to be even, which like I gave you example of 5 and 2. Because whenever from subtraction of two numbers I get an odd number, so the one number out of those two numbers has to be odd and one has to be even. For example, 5 and 2. For example, 7 and 4. Okay, so that means one number out of these two was what? Odd, and if one was odd, then the other was even. I hope you people understood this. I know it was a very, very long explanation, but this is how you were supposed to do. So I hope you understood this. Now let's move on to the next question. Okay, so the next question states that we need to find the LCM and HCF of the following pairs of integers, and we need to verify that LCM into HCF is the product of integers. Okay, this is also one of the questions from R.D. Sharma, and there are three parts of it. So let's do one thing. I'll be taking up part 2 of this question, and the rest, that is part 1 and part 3, are your homework. So you will see and you will observe that how I'm solving part 2 of this question, and then after understanding it, you are going to solve part 1 and part 3 of this question. So let's start. So let's first find the factors of what? 510 and 92. Correct? So we know that 510 is equal to nothing but 2 into 3 into 5 into 17. You can do prime factorization to find out the factors. Similarly, for 92 itself, it has to be 2 into 2 into 23. Now, if I want to find out the LCM of 510 and 92, and now LCM is what? Lowest common multiple. So lowest common multiple means that all the prime numbers which are there, I basically have to multiply the greatest powers of it. So like when I talk about 2, so 2 is at max 2 times. So I'm going to multiply 2 at max 2 times. 3 is what? Only 1 time. So I'll multiply at max 1 time. 5 is at max what? 1 time. 17 is at max what? 1 time. And 23 is at max 1 time. So the LCM will come out to be what? 23460 when I'm going to multiply all of this. And similarly, I need to figure out the HCF. So HCF is the highest common factor. So for the common factors, we only have 2 as a common factor, right? So I know what is LCM, I know what is HCF. When I multiply LCM into HCF, okay, so LCM into HCF is what? 23460 into 2, which is nothing but 46920. So this is the multiplication of HCF and LCM. And when I find the product of integers, that is 510 into 92, I get what? I get 46920. So this number and this number, both of them are what? Both of them are equal. Hence it's verified that any two number given where HCF into LCM will be equal to the product of those two numbers. I hope you understood this. So let's move on to the next question now. Alright. So let's see what does the next question states. The next question states that we need to determine the number that is nearest to this number, but it's greater than this number, which is exactly divisible by what? Exactly divisible by 8, 15 and 21. So I basically need to figure out a number that is greater, which is nearer to the number that is given here, but it is actually greater than this number. So this is like the minimum threshold which we need to take. So the number has to be greater than this. And that particular number is divisible by 8, 15 and 12. So I've got three numbers, 8, 15 and 21, sorry. And I basically need to find a number that is divisible by all three. So if I'm going to find the LCM of this, so LCM is going to be what? The lowest common multiple. But for LCM, I have to do what? Prime factorization. So 8 is nothing, 8 is 2 into 2 into 2. Then 15 is what? 15 is nothing, it is 3 into 5. And 21 is nothing, but 21 is 3 into 7. So LCM is going to be what? 2 into 2 into 2 into 3 into 5 into 7. Okay, and this is going to be what? 840. So after multiplying all of this, I get what? 840. Now, when this number, that is 110000, which is what? 1,10,000 is divided by my LCM. So if I divide this number by my LCM, the remainder is of this division is going to be what? 800. Correct? So when I divide it, the remainder is going to be what? 800. Now, subtracting my remainder from this number, I'll get what? Quickly. Subtracting my remainder from this number, we are going to get what? We are going to get 109200. Okay, and this number is divisible by each of the number, that is 8, 15 and 21. Alright, so this number is what? This number is divisible by that. Also, we basically figured out 840, but we split 840 into 800 plus 40. And you can see that I have done my subtraction with 800. But what about 40? So if I'm going to add 40 to this number, so I'll get what? 110040. That is again divisible by 8, 15 and 21. Correct? So hence, this number and this number, both of these numbers are greater than this number. That is my 1 lakh. So both of them are greater than this. But we need to figure out which one is closer to this number. So the number which is closer to this number is the second number. That is 1,10,040. So this number is closer to that number. So this is the number which we are going to report. So let's see how to solve this question one more time in case any of you got lost between the explanation. So basically what I was saying is that we need to find out a number which is nearer to this number, but a number that is greater than this number, which is exactly divisible by 8, 15 and 21. So to figure out that, I first of all calculated the LCM of 8, 15 and 21, and I found out that the LCM is 840. Alright, now I need to figure out with respect to this, because I need a number which is nearer to this. So just by guessing and applying some techniques, I subtracted 800 from it and I added 40 from it. Okay. Now why I subtracted 800? It also has a reason to it. And the reason is that when I'm going to divide this number by the LCM, the answer that I get is what? It's actually 800. Okay, so when I divide it by 840, I get what? 800. And that is the reason why I split 840 into 840. Okay, it's just not about trial and guessing, it's also about a little bit of mathematics that we applied. So we actually divided the number and we found out 800. So we thought that alright, maybe one number could be 800 by which we can found a number, and the other can be 40 and the total can be what? 840. So when we subtracted 800 from this number, okay, when we subtracted, I got this number. Okay, and when I checked, then 8, 15 and 21, all of these three divided this number. Similarly, when I added 40, all these three numbers were able to divide this number. And out of these two numbers, the second number is the number which is closer to this and which is greater than this number. So I reported that my answer is going to be what? 110040. So this is the number that I am going to report for the answer. I hope you understood this. So let's move forward and solve the last question for the day. And this question is also of R.D. Sharma. Alright, so basically they are saying that we need to express the HCF of this equation, that is 468x plus 222y, where x and y are what? They are integers. Okay, so we are going to use Euclid's division algorithm here. Okay, now I can write 468 as what? 222 into 2 plus 4, correct? Similarly, 222 can be written as what? 24 into 9. Sorry, here it's going to be 24 because if I multiply 222 by 2, it's going to be 444. So I have to add what? 24 to it to get 468. So now for 2 to 2, I have to multiply 24 with 9 and I have to add 6 to it to get 222. Similarly, for 24, I have to write 6 into 4 plus 0. Correct. Now, similarly, children, if you're not able to understand that how these equations come, I have explained this like in a very elaborative way in the previous video. And you can just go there, like pause this video, go to the previous video, just see why these equations come and like what is the, I would say explanation behind why we write these equations in that video. So you can just go and understand it here and then come back and try to solve this question. So yes, so basically I will tell you just one hint that we are using Euclid's division algorithm here, as simple as that. And we have just applied that theorem, that is A equals to B cube plus R. Okay, we have just applied this theorem here and we have repeatedly done those divisions. Now, since the remainder is 0, so what is the HCF? Come on people, what is going to be the HCF? It's going to be 6, right? Now, we need to use the above equations. So, we can say that 6 is nothing but what? 6 is 222 minus 24 into 9. So, this is the equation which we used here. So, I found HCF 6. So, I use this equation to figure out what is 6. Now, can we write 24 in a particular term? Like 24 in a particular term? Yes, of course, why not? Here, use equation 1 in this. So if I'm going to use equation 1, like this equation to write this. So this equation, this equation is going to be 6 equals to 222 minus. Now 24 can be written as what? 468 minus 222 into 2, and this whole will be multiplied, this whole will be multiplied by what? 9. Correct? So this is what? This is my equation number 2, where we know that 468 was what? 222 into 2 plus 24 by equation number 1. Now if I'm going to solve it, so I can distribute 9 in this. So I'm just going to erase a little bit. Okay. So 6 is going to be nothing, but it's going to be 222 minus 468 into 9 minus 222 into 2 into 9. So I've just distributed this. So if I further solve it, it's going to be 6 equals to 222 minus 468 into 9 plus 222 into 80. Correct? Correct. So this is going to be that 6 equal to 222 plus 222 into 80 minus 468 into 9. Correct? Correct. Now we have 222, so I can further solve this and take this common. I'm just going to erase this. Okay, so we are going to further write it down now. So it's going to be what? It's going to be 6 equals to 222 is common, so it's going to be 18 plus 1 minus 468 into 9. Now 18 plus 1 is what? 9. So again I'm going to take what? 18 plus 1 is going to be 19. So it's going to be 222 into 19 minus 468 into 9. So 6 is going to be what? 468 times minus 9 plus 222 into 19. So this is the equation that we found out at the end. So HCF of 468 and 222 in the form of this, that is 468 into x and 222 into y, can be represented as this, where x is nothing but x is minus 9 and y is nothing but y is 19. So hence we have figured out how to write that in form of this equation. So yes, it was a little bit tricky. You have to apply your brain and common sense as to how you can find the equations to solve the question. So I hope you people have understood what all real numbers are now, because in the first video we talked about real numbers in depth, we understood all the concepts, and in this video we did the questions. So now what you can go and do is you can go to EduRev and attempt the test to understand this chapter in depth. You can unlock all the logged videos, documents and tests for class 10th with EduRev Infinity Plan and ace your exams at less than 80 rupees per month. Thank you.